I would suggest thinking of enzymes as individual machines in a factory. Here's the input to the factory, this ore coming down as a substrate. These furnaces are the enzymes processing the substrate of ore into plates. An example of induced fit is shown here, as the robotic arms must move to allow the substrate in and out of the enzyme. Here's an example of negative feedback. Once the product here in this chest exceeds a certain number, it will cause this power switch to disconnect and prevent any of the machines from functioning. This also shows non-competitive inhibition, as removing power stops the reaction without having to remove the substrate first. An example of competitive inhibition would be changing the recipe in this machine. This substrate is removed once this happens, and it can no longer function until the recipe is put back in, which will allow the enzyme to function properly. An example of a cofactor or coenzyme would be like power to a machine. Machines cannot function without power. When I turn the power on, it will allow these machines to function, and when I turn the power off, they can no longer function. Down here is an example of a quaternary structure. Once the active site has a substrate in it, all 4 enzymes will start functioning. Once it runs out of substrate, they will stop functioning. As you can see here, they all turned off. Finally, machines break at high temperatures, just like enzymes denature at high temperatures. That is one sturdy train.